Welcome children in geography class. In the previous chapter, we have studied about conventional sources of energy in which we have done coal and petroleum. These energy resources are exhaustible. They cause pollution, emits greenhouse gases which results in global warming. So, there is a need to find out the alternative sources of energy. Today's topic is non-conventional energy resources, also known by the name renewable or alternative sources of energy, in which we will study about solar energy, wind energy, nuclear energy and biogas generation and their advantages. Let's start first with solar energy. Sun is the ultimate source of energy. Traditionally, we have been using solar energy for drying clothes and food grains, preservation of eatables and also for obtaining salt from seawater. India is fortunate enough to receive higher amount of solar energy, that is equal to 5000 trillion kilowatt per year. And children, what is the reason? The reason is that the tropic of Cancer passes through the middle of India and divides India into two equal halves. That is why we have 300 clear sunny days in a year, and per hour per square kilometer availability of solar energy is between 5 to 7 kilowatt. So, children, I am giving you one question here, that name the 5 states from which the Tropic of Cancer passes, and this we will be discussing in the interactive class. Now, what are the ways that we can use this solar energy in different forms so that we can save the conventional sources of energy? So, there are several techniques have been developed in India for harnessing solar energy, and these are like the solar heater is there, photovoltaic cells are there, then solar heater is there, solar cooker is there. So, there are so many appliances that we can use for harnessing this solar energy. What are the advantages of using solar energy? As I have already said, that these are the renewable resources of energy, as well as they are eco-friendly. They are the clean source of energy, zero carbon emission from them. There is a less dependence on the fossil fuels, and they also provide income to the people because they generate employment sources also for the people. So, there are so many advantages of using solar energy as a source of energy. This is a wind farm in which the wind energy is obtained by making use of these windmills. The blades of the windmills rotate due to the force of the wind. A number of windmills are installed in a definite pattern in cluster so that a large amount of electricity is obtained. Wind farms are generally installed in coastal areas, hilly regions, desert areas as well as the remote areas, because the remote areas are not connected to the electric power grid and can use wind power to create their own supply of electricity that can be used for the machines like water pumps, floor mills as well as the electric generators in the rural areas where there is no other means of electricity. And in India, particularly the coastal areas of our country like Andhra Pradesh, Tamil Nadu, Gujarat, Karnataka, Kerala, these wind farms have been established. How is this wind energy obtained with the help of this windmill? The blades catch the wind and spin. Generator converts mechanical energy into electrical energy. Cable wires carries electricity to transmission lines, and computer system control the direction of the blades so that they can move fast and generate maximum of electricity. What are the advantages of wind energy, children? It is a clean electricity because there is no carbon emission from this. No greenhouse gases are released. It is an inexhaustible source of energy, that means renewed again and again. Come in all different sizes, we can obtain in any area. Land under wind turbines can still be used and good for people in remote areas, as I have already said, because there is no other means of electricity in the remote areas. So, this is the best way that we can obtain the electricity with the help of wind energy. Now, we will learn about nuclear energy and biogas energy with the help of this video.
Biofuels are combustible fuels created from biomass. The term biofuel is usually used to describe liquid fuels such as ethanol and biodiesel that are used as replacements for transportation fuels like gasoline, diesel, and jet fuel. Ethanol is an alcohol formed by fermentation. It is used as a replacement for or additive to gasoline. Biodiesel is an oil produced by extracting naturally occurring oils from plants and seeds. Biodiesel can be combusted in diesel engines or blended with diesel fuel. Biofuels are grouped in 3 categories based on the type of feedstock used to produce them. First-generation biofuels are produced from food crops. For ethanol, feedstocks include sugarcane, corn, maize, and others. For biodiesel, feedstocks are naturally occurring vegetable oils such as soybean and canola. Second-generation biofuels are produced from cellulosic material such as wood, grasses, and inedible parts of plants. This material is more difficult to break down through fermentation and therefore requires pre-treatment before it can be processed. Third-generation biofuels are produced using the lipid production from algae. In addition, the term advanced biofuels is used to describe the relatively new technological field of biofuel production that uses waste such as garbage, animal fats, and spent cooking oil to produce liquid fuels. Biofuels are currently the only viable replacement to petroleum transportation fuels because they can be used in existing combustion engines. This is an increasingly important advantage with growing concern about the environmental impacts of fossil fuels around the globe. Biofuels can also help provide energy security in regions that do not have hydrocarbon resources but do have suitable agricultural conditions. While there is some dispute over just how renewable biofuels are, it is generally accepted that the crops used to produce them can be replenished much faster than fossil fuels, which take millions of years to form. Concerns about biofuels are usually centered around the fact that they are an agricultural product. Producing these biofuel crops can mean competition with other natural resources, particularly land, food, and water. First-generation biofuels use only edible crops, which has led to biofuel crops displacing food sources in certain regions and subsequent spikes in food prices. In many regions of the world, subsidies are provided for these crops, which only amplifies these issues. In addition, increased agriculture of any form comes with concerns of deforestation and biodiversity loss, as well as water and fertilizer use, which have environmental and climate impacts all to their own. That's biofuels.
What is biogas? Biogas is a clean, sustainable, and economically friendly source of energy. How does biogas produce? Biogas is produced through a natural process called anaerobic digestion that turns organic waste, like animal waste and food waste, into two products. The first product is a clean gas called biogas. It is used mainly in rural area for lighting, heating, and cooking. The second one is a high-quality organic fertilizer, which is used by the farmer for their plants to replace the chemical fertilizer.
Nuclear energy is the energy held in the nucleus of an atom. It can be obtained by 2 types of reactions, fission and fusion. Nuclear fission produces energy through the splitting of atoms, which releases heat energy that can be harnessed to produce electricity. The fuel most commonly used for nuclear fission is uranium. However, other elements such as plutonium and thorium can also be used. All of today's operating nuclear plants use nuclear fission to generate electricity. The second type of nuclear energy is nuclear fusion, the same process that powers our sun. Fusion is a nuclear reaction in which atomic nuclei collide at a high speed and join to form a new type of atomic nucleus. During this process, matter is not conserved because some of the matter of the fusing nuclei is converted to photons, which produces energy. Fusion power offers the prospect of an almost inexhaustible source of energy. However, creating the conditions for nuclear fusion presents a potentially insurmountable scientific and engineering challenge. A recent experiment has shown that nuclear fusion can be achieved. However, it has not yet been successfully demonstrated on a commercial scale. Today, nuclear power plants account for 11% of global electricity generation, with about 80% of that installed capacity being in OECD countries. All of this capacity is nuclear fission. Nuclear energy, through fission, can release 1 million times more energy per atom than fossil fuels. Nuclear plants have large power generating capacity and low operating costs, making it ideal for baseload generation. Because of its large scale and centralized nature, it can easily be integrated into electricity grids, requiring few changes to existing infrastructure. However, upfront capital costs are intensive and present financial risks to investors given the long time frames power plants must operate to recover these costs. Nuclear energy does not emit greenhouse gas emissions. For this reason, it is often seen as a substitute for fossil fuel electricity and a solution for mitigating climate change. However, nuclear power holds a wide variety of environmental and health issues. The largest concern is the generation of radioactive wastes such as uranium mill tailings, spent reactor fuel, and other radioactive wastes. Some of these materials can remain radioactive and hazardous to human health and the environment for thousands of years. Several nuclear accidents in recent history have negatively impacted the environment and surrounding communities, making nuclear power a controversial topic for the general public. That's nuclear energy.
After watching this video, children, you might have understood how biogas and nuclear energy is produced. What are their advantages? Children, you will find out what is the raw material that is required to produce biogas and nuclear energy, as well as you will also find out the names of the 4 nuclear power plants in India, in which states these nuclear power plants are located. I will be discussing all these questions in my interactive class. Thank you, children. God bless you.